Hi everyone. In this video we're going to be talking about value adaptive instruction, which is a scalable method for measuring and addressing bias in educational technologies. My name is Nick Diana and I'm a PhD candidate in the Human-Computer Interaction Institute at Carnegie Mellon University. My work is primarily in educational technology with a specific focus on ill-defined domains like civics and informal reasoning. If you're interested in learning more about this work or potentially collaborating, feel free to reach out to me at this email address. So this talk is going to be divided into two parts. First, we're going to be defining what value adaptive instruction is, and then we're going to discuss one potential method for implementing it in a scalable and theory-driven way. But to understand why value adaptive instruction might be a useful tool, we first need to take a step back and talk about bias. Specifically, one particular kind of bias called my-side bias, which occurs when people evaluate evidence and test hypotheses in a manner that's biased towards their own prior opinions and attitudes. Importantly, the extent to which one exhibits my-side bias is not related to one's intelligence. Even smart people exhibit this bias. And there's a known interaction with age, with older people tending to exhibit more my-side bias than younger people. We're not certain why this is the case, but one possible explanation is that older people tend to rely more on heuristic reasoning, essentially reasoning shortcuts based on past experience. Heuristic reasoning is generally great most of the time, but these shortcuts also leave you more open to bias. Anecdotally, you might know some people who exhibit a lot of my-side bias. When these people hear something they disagree with, they'll be immediately skeptical. But when they hear something they agree with, they'll blindly accept it as true. The important takeaway here, though, is that in both cases, the amount of critical thought that they're exercising is dependent on this relationship between their values and the values latent in the content they're consuming. We call this relationship between user values and content values alignment. And we expect that when alignment is high, people will be more biased, that is, less likely to engage their critical thinking faculties. So if we want to design instructional technologies that help people practice overcoming their my-side bias, we need to have some working knowledge of what they value, the values latent in the content they're consuming, and then some way to relate those two things to one another. This is one example of what we're terming value adaptive instruction, which we define as instruction that recognizes that there's a dynamic relationship between our own values and the values latent in what we're reading or listening to, and that by adapting instruction based on that relationship, we can improve the efficiency of skill acquisition. Value adaptive instruction is particularly useful when designing instruction for three types of skills. First, it allows us to provide targeted justification requests, which is when you ask students to defend a position that they agree with. Second, it allows us to make targeted perspective-taking requests, which is when you ask students to defend a position that they disagree with. And then the final and most important benefit of value adaptive instruction is its potential ability to measure and eventually combat against powerful biases like my-side bias. As far as we know, this kind of value adaptive instruction has never been implemented in any educational technology. But it's worth noting that teachers do this kind of thing all the time. The civics teachers that we interviewed as part of this work would tell me that, for example, if they know a particular student is pro-gun rights, they'll purposely assign them to defend a pro-gun control position. So teachers understand that there's a big difference between justifying a position you agree with and justifying a position that you don't agree with. Unfortunately, with one teacher, this kind of adaptation isn't scalable. So just to give an idea of the scale of this problem, if we say a teacher teaches 5 classes a day and has about 20 students per class, and each class covers about 25 topics a school year, which is about 1 a week, that ends up being about 2,500 student topic combinations that the teacher would have to kind of memorize or know about in order to adapt instruction to each student. So the result of this is that value adaptive instruction just doesn't happen in the classroom that much. It only happens occasionally and only for a handful of students who happen to be particularly vocal about specific beliefs. And this is where we think educational technology might be able to help. So the remainder of this talk is going to focus on one potential way to implement a value adaptive system in a way that's both scalable and theory driven. It all hinges on estimating this alignment construct, which remember is this relationship between a user's values and the values latent in the content they're consuming. Generating this estimate requires 3 steps. First, we need to estimate user values, which we do by using the Moral Foundations Theory questionnaire. Then we need to estimate the values latent in the content the user is consuming. And we do this using natural language processing. And finally, we need to relate these two sets of values to one another, and we do that with cosine similarity. So let's talk about how we estimate user values. Like I said, we estimate user values using Moral Foundations Theory, which argues that there are several innate and universally available psychological systems which form the foundations of intuitive ethics. The authors of Moral Foundations Theory argue that there are at least 5 or 6 of these foundations. We use the 5 foundation model, which includes care, fairness, loyalty, authority, and sanctity. Now, research has shown that different groups of people, like liberals and conservatives, tend to prioritize different values. Liberals tend to weight care and fairness much more heavily than the other 3 foundations, whereas conservatives tend to have a more equal distribution across all 5. So this is how we estimate user values. Now let's talk about how we estimate the values latent in content using natural language processing. We use a method that's based on the distributional hypothesis, which is best summarized by J.R. Firth's famous quote, "You shall know a word by the company it keeps." Essentially, we would expect that concepts that appear in similar contexts are semantically similar. For example, if we were given these 2 sentences, the Zordif she picked was juicy and the Quindar she picked was juicy, we can't say a lot about these 2 fictional fruits, but we could be confident that they share features like being juicy and being pickable. And by training our model on a very large corpus of text, we can use these varying contexts to begin to approximate meaning. The distributed representation of a word is simply that word's location in a low-dimensional space. The distance between objects in this space represents the semantic distance between them as well, so we expect that closely related concepts are going to be spatially closer to one another. Recently, Garton and colleagues have extended this work to include more traditional psychological concept dictionaries, which lets us use psychological constructs like the values in Moral Foundations Theory. Essentially, we can compute the semantic distance between a concept dictionary and a small body of text. And we do that by averaging the distributed representations of all dictionary terms, and then computing the average cosine distance between the concept representation and the representation of each word in the text. In practice, this allows us to take as input short pieces of text, like, for example, this tweet, and then output the semantic distance between that text and each of our 5 moral foundations. So in this graph, there are blue and red bars, which are coded for positive and negative dictionary terms. So according to our model, this tweet mostly is evoking the negative aspects of the authority foundation, which we defined with this concept dictionary. Okay, so we've estimated user values using a theory-driven questionnaire, and we've estimated content values using NLP. The output of both of these processes is a vector of 5 scores, one for each of the 5 foundations. And by computing the cosine distance between these 2 vectors, we get our measure alignment, which again is the extent to which the user's values match the values latent in the content. So we ran an experiment to test whether alignment could reliably be used to predict bias. We recruited 60 participants and had them perform an argument evaluation task where they were asked to rate the strength of 20 arguments on a 9-point Likert scale. Each argument had 2 key features: the foundation that it appealed to, so we had arguments that dealt with fairness and loyalty, etc., And the second feature was the relative quality of the argument, with higher quality arguments being supported by more or better evidence. We tested the impact of alignment on a participant's ratings of argument strength with a mixed effects model, with strength rating as the outcome measure, quality, alignment, and age as fixed effects, and student and problem as random effects. Note that we include an alignment by age interaction term due to known interactions between these two features. Here are the results of the model. We can see that alignment is predictive of ratings of strength, and the interaction term is also predictive, suggesting that there is a relationship between bias and age that has been observed in other studies. This graph shows alignment by ratings of strength across arguments grouped by quality. We can see that people generally rated high-quality arguments as stronger, which is good, but also that alignment is positively correlated with ratings regardless of argument quality. This graph again shows alignment by ratings of strength, but this time the data is separated into older and younger participants. We can see that the relationship between alignment and ratings is much stronger in older participants, which again replicates prior findings in this area. This experiment demonstrated that our construct of alignment between user and content values was a reliable predictor of bias, and that the impact of alignment persisted even in the presence of features like argument quality and participant age. So to summarize, first, addressing my-side bias requires instruction that recognizes there's a dynamic relationship between our own values and the values latent in the content we're consuming. And second, value adaptive solutions are typically unscalable, but by combining theory-driven estimates of user values with estimates of content values derived using NLP, we can use educational technology to measure the impact of my-side bias on argument evaluation tasks in a scalable way. Thanks for watching, and please feel free to forward any questions or comments to me at this email address. Thank you.